Welcome to Coding Wizards, your one-stop destination for mobile app developers.
Hey everyone!
Today, you've told us you want to sharpen your Flutter interview skills, no matter where you are on your learning journey.
Yeah, we got a lot of requests for this.
So we've structured this deep dive like a simulated Flutter development interview. We'll hit beginner, intermediate, and even advanced topics.
Exactly. The goal is to give you a feel for the types of questions you might face and the level of detail expected.
Think of it as your personal prep session. Let's jump right in with some fundamentals.
All right, let's start right at the beginning. Imagine I'm totally new. How would you explain what Flutter is?
Okay, good starting point. So if you're brand new, think of Flutter as a toolkit. A really powerful one, actually, made by Google.
Okay, a toolkit.
Yeah, they released it back in May 2017. The big deal is it lets you build apps that look and feel native
Right.
for a whole bunch of platforms, like
Right.
Android, iOS, even desktop Windows, Mac, Linux, and Web 2. And the key is, it's all from one code base.
That single code base is huge. Saves a ton of effort.
So why did Google build it this way? What are the main benefits?
Well, speed is a big one. Flutter's designed to help you build really nice-looking apps fast.
Performance, yeah.
And they talk about expressiveness, meaning you get tools to make cool UIs without, jumping through hoops. And honestly, it feels like it's becoming a major way people build apps across devices.
Definitely seems that way. Now, every Flutter app uses a specific programming language. Which one is that? And tell us a bit about it.
That would be Dart, another Google creation, actually.
Ah, Dark. Okay.
Yeah, its main focus is client-side stuff, apps on your phone or browser. But it can do server and desktop work, too.
And what kind of language is it?
It's object-oriented, uses classes, has garbage collection for memory. The syntax feels a bit like C++ or maybe Java. If you know those, it'll seem familiar.
Okay, C-style syntax. And why Dart for Flutter? What makes it a good fit for UI development? There are a couple of cool reasons. First, how you build the UI. In Dart, you define the layout right in the code. No separate XML or anything like that.
So no separate layout language.
Right, it's all Dart, which many find easier to read and visualize. Plus, during development, Dart uses JIT, just-in-time compilation.
JIT, yeah. That powers.
Exactly, that powers hot reload.
Yeah.
Lets you see code changes almost instantly in the running app. Huge productivity boost.
Absolutely essential feature. Okay, shifting gears slightly. In every Flutter project, there's that pubspec.yaml file. What's its deal? What does it do?
Right, the pubspec.yaml, it's basically the project's brain, its configuration center, sits right at the top level of your project.
Okay.
It tells Flutter and Dart everything they need to know, like what external packages your project uses and which versions.
Dependencies.
Exactly.
Yeah.
Also lists things like custom fonts, images, even developer-only dependencies for testing. And it specifies which Flutter SDK versions are compatible.
And you don't write this from scratch, right? It gets generated.
Correct. When you run Flutter Create, it makes one for you. And it's written in YAML, which is, well, designed to be pretty human readable.
Good stuff. Now, inside the Dart code itself, we always see main and run app. What's the difference there?
Okay, main is the absolute starting point. Your whole Dart program kicks off from main.
The entry point.
Precisely. And inside main, you almost always call run app.
Right.
Run app takes a widget, your main app widget usually, and basically blows it up onto the screen, makes it visible.
So main starts the engine, run app, puts the car on the road.
Haha, yeah, something like that.
Yeah.
Run app attaches your widget tree to the UI.
Okay. And when defining functions or widget constructors in Dart, we see positional and named parameters. Can you break down that difference?
Sure. Positional parameters are like in many other languages. Order matters when you call the function.
Right. First argument goes to the first parameter, etc.
Exactly. And they're required by default unless you mark them optional with square brackets.
Okay. And named parameters.
Named parameters use curly braces in the definition. When you call the function, you use the name, like parameter name, value. Order doesn't matter.
More flexible.
Yeah, and they're optional by default. You can make them required with @required or the required keyword in null safety.
Got it. Positional relies on order. Named relies on the name itself. Now, UI, we always hear, in Flutter, everything is a widget. What does that really mean?
It's fundamental, yeah. It means widgets are the absolute basic building blocks for everything you see on screen.
Everything, like layout, too.
Everything. Layouts like row and column, text, images, buttons, padding, even things you don't directly see but affect layout or state. It's all widgets.
So the whole UI is just a big tree of these widgets nested inside each other.
Exactly. A hierarchical tree. Each widget has a specific job layout, display, interaction, whatever.
Cool. Now, for developers, hot reload and hot restart are lifesavers. Explain those and the difference.
Right. Hot reload is the super fast one. You change code, hit save, and Flutter injects the changes into the running app. Usually preserves the app state too.
So you don't lose your place on the screen.
Most of the time. Yeah. Hot restart is slower. It completely restarts the Dart VM. You lose the current app state, starts fresh.
When would you need hot restart instead of hot reload?
If you change something hot reload can't handle, like native code, major state logic, or sometimes if things just get weird, or if you change dependencies in pubspec.yaml.
Okay, makes sense. Flutter is often called open source. What does that term mean for software?
Open source means the source code, the actual human-readable code, is freely available for anyone to see, use, modify, and even distribute.
So it's not locked down.
Exactly.
Yeah.
It usually comes with licenses saying what you can and can't do, but the core idea is openness and collaboration.
And is Flutter itself open source?
Yes, absolutely. Google develops it, but the code is out there on GitHub for anyone to contribute to or use under its license. Big community effort.
Great. When building UIs, we constantly use stateless widget and stateful widget. What's the fundamental difference?
The core difference is whether the widget can change its own internal data over time. The stateless widget is immutable. Once you build it with certain properties, those properties don't change. Think text, icon, simple container.
Static things.
Right. A stateful widget, however, can change. It has associated mutable state that can be updated during its lifetime, usually in response to user interaction or data changes.
But that involves a separate state object.
Exactly. The stateful widget creates a state object, and that state object holds the data that can change and triggers rebuilds when it does. Think checkbox, text field, anything interactive.
Got it. Stateless is fixed. Stateful can change via its state object. Now, extending Flutter. Packages and plugins, what are they and what's the difference?
Okay, both let you add functionality.
Yeah.
Packages are basically shareable bundles of Dart code. Classes, functions, utilities. You add them as dependencies.
Like reusable code libraries?
Exactly. You might grab a package for making HTTP requests or for some cool chart widget. Plugins are a special kind of package.
Special how?
Plugins include native platform code, Java Kotlin for Android, Swift Objective-C for iOS.
Ah, so they bridge the gap to the underlying platform.
Precisely. You need to access the device camera, GPS, Bluetooth, things like that. You'll typically use a plugin that handles the native communication.
So packages are Dart only. Plugins involve native code. Clear. And it's worth noting, many popular big-name apps are actually built with Flutter these days.
Oh, for sure. It's definitely proven itself capable of handling complex, real-world applications used by millions.
Good point. Back to Dart keywords. Final, const, static. How do they differ?
Okay. Final means a variable can only be set once. Its value is determined at runtime and then can't be changed.
Set once, runtime value. Got it.
Const is stricter. It's a compile time constant. The value must be known when the code is compiled. Think mathematical constants or fixed configuration values.
Right.
Const objects are deeply immutable.
Compile time, immutable.
Okay.
And static.
Static applies to class members, variables, or methods. It means the member belongs to the class itself, not to any specific instance object of the class.
So you access it using the class name?
Right. Like myClass.staticVariable or myClass.staticMethod, without needing to create an object first. Same value or method for all instances.
Makes sense. Now that fat arrow syntax, what's that for?
Ah, the fat arrow. It's just shorthand for functions that contain only a single expression.
Like a one-liner function.
Exactly. Instead of return expression, you just write expression. It's cleaner for simple functions.
Nice little syntax, sugar. Okay, layout time, safe area. Why do we use that widget?
Safe area is crucial for dealing with device screen intrusions like notches, status bars, or those home indicator areas on iPhones.
The bits that can overlap your UI.
Right. You wrap your main content, or parts of it, in a safe area, and it automatically adds padding to avoid those areas, keeping your actual UI visible and interactive.
Very useful. Inside rows and columns, we have main axis alignment and cross-axis alignment. What do those control?
They control how the children inside the row or column are positioned. Main axis alignment deals with alignment along the primary direction.
So horizontal for row, vertical for column.
Correct. You can align children at the start, center, end, or distribute space between them. Cross-axis alignment handles alignment perpendicular to that.
Vertical for row, horizontal for column.
Yep. Aligning them at the start, end, center, or stretching them across the cross-axis.
Main is along the flow, cross is perpendicular. Got it. How about container versus sized box? One use which?
The container is like the versatile box. You can give it size constraints, padding, margin, borders, background colors, gradients, images.
Yeah.
It can decorate and position a child.
A real jack of all trades?
Pretty much. Size box is much simpler. Its main job is just to create empty space or to force a child to have a specific width or height.
So size box for simple spacing or sizing, container for more complex styling and layout around a child.
That's a good way to put it, yeah.
Okay, Dart's null-aware operators. Quick rundown.
Super useful for null safety is optional chaining. Object.property accesses property only if object isn't null. Otherwise, the whole thing is null. Avoids errors.
Safe access.
It is the null coalescing operator. Value 1. Value 2 returns value 1 if it's not null. Otherwise, it returns value 2. Great for default values.
Default fallback.
And in dis is null-aware assignment. Variable. Value assigns value to variable only if variable is currently null.
Assign if null. Handy. Okay, text input, text editing controller. What's its role?
It lets you manage the text inside a text field. You can use the controller to read the current text, set the text programmatically, control the cursor position, listen for changes.
So it's the bridge between your code and the text field's content.
Exactly. Gives you programmatic control.
What about maintaining proportions, like always wanting a widget to be square?
For that, you'd use the aspect ratio widget. You give it a ratio like 1.0 for square, and it forces its child to conform to that width-to-height ratio within the parent's constraints.
Ensures the shape stays consistent. Useful. And the assert statement, what's that for?
Assert is purely a debugging tool. You use assert condition to check if something you expect to be true actually is true during development.
And if it's false?
It throws an assertion error and usually pauses execution in debug mode. Helps catch bugs early. Importantly, asserts are completely ignored in release builds.
So no performance hit in production. Good. How do we usually talk to web servers? Make HTTP requests.
The standard way is using the HTTP package. You add it to your pubspec.yaml.
Okay.
Then you import it and use functions like http.get, http.post, etc. You pass the URL, maybe headers or a body.
And it gives you back a response.
Yeah, you get a response object with the status code, body, headers. You'll often parse JSON from the response body.
Standard stuff. What are the core technologies Flutter itself is built on?
Well, the language is Dart, as we said. The Flutter framework, which has all the widgets and APIs you use, is written in Dart.
Okay.
Underneath that is the Flutter engine. It's mostly C++A, provides the runtime, talks to the OS, and uses the Skia 2D graphics library for actually drawing everything.
So Dart framework on top of a C++ engine using Skia. Got it. Back to stateful widget lifecycle. In a state. When and why?
Init state is called exactly once, right after the state object is created, but before the build method runs for the first time.
Only once, at the very beginning.
Right. It's perfect for one-time setup. Initializing variables, setting up controllers, subscribing to streams, stuff you only need to do once when the widget first appears.
Makes sense. And its counterpart, dispose.
Dispose is called when the state object is being permanently removed from the widget tree. It's the cleanup method.
Time to release resources.
Exactly. You need to dispose of controllers, cancel stream subscriptions, remove listeners, anything that might cause memory leaks if left hanging around after the widget is gone.
Crucial for preventing leaks.
Yeah.
Okay. Layout basics. Padding versus margin. The difference.
Padding is space inside a widget's bounds, between its edge and its content. It makes the widget effectively larger inside.
Inside space.
Margin is space outside the widget's bounds, creating a gap between it and its neighbors or parent. It affects positioning, not the widget's internal size.
Outside space, got it. Scaffold widget. What's its main purpose?
Scaffold provides the basic material design visual layout structure for a screen. It gives you slots for common things like an app bar, a body, a floating action button, a drawer, bottom navigation bar.
Sort of a pre-built screen template.
Yeah, it handles the placement of those standard material components, giving you a consistent foundation.
And the expanded widget, how does that work in rows and columns?
Expanded tells its parent, row or column, that its child should take up all the remaining available space along the main axis.
Fills the leftover space.
Exactly. If you have multiple expanded widgets, they share the space based on their flex factor.
Okay. What if my content is too big for the screen? How do I make it scrollable?
The simplest way is often the single child scroll view widget. You just wrap your large content widget with it.
And it just scrolls.
Yep. If the child is taller than the available space, it becomes vertically scrollable. If wider, horizontally scrollable. Handles overflow.
Easy enough. How about layering widgets on top of each other?
For that, you use the stack widget. Children of a stack are layered, with later children drawn on top of earlier ones.
Like a stack of paper.
Exactly. And you can use the position widget inside a stack to precisely control where each child sits within the stack's bounds.
Ah, position gives you fine control within the stack. Okay. What's a theme in Flutter?
A theme defines the overall visual style, colors, fonts, button styles, etc. for a part of your app, or the whole app.
Centralized styling.
Right. You define theme data, and widgets within that theme scope automatically inherit those styles. Great for consistency and making app-wide style changes easily.
Makes sense. How do we conditionally show or hide a widget?
The visibility widget is common for this. You give it a Boolean visible property. If true, the child is shown. If false, it's hidden.
Simple enough. And basic screen navigation, how's that typically done?
Usually with a navigator widget, you use methods like navigator.push to go to a new screen, pushing a new route onto the stack, and navigator.pop to go back, popping the current route.
A stack of screens.
Essentially, yeah. Flutter manages that stack for you.
What's that UI element that slides up from the bottom? A modal bottom sheet?
Yep, modal bottom sheet. You show it using the show modal bottom sheet function. You give it a builder function that defines its content. It slides up and dismisses when tapped outside or navigate away from.
Got it. We mentioned positioned inside stack. How do its properties like left, top, right, bottom work?
They let you anchor the edges of the positioned child relative to the edges of the parent stack.
Left.
10 means the child's left edge is 10 pixels from the stack's left edge.
So you pin it to the sides.
Exactly. You can specify 1, 2, or more sides to control position, and sometimes even size if you specify opposing sides like left and right.
Okay. How do we pass data between screens when we navigate?
Several ways. Simple way is just passing data to the constructor of the next screen's widget when you create it for navigator.push.
Constructor arguments. Clean.
Yep. You can also use the arguments parameter of navigator.push itself, which can hold any object. Access it on the next screen via modal route.ofcontext.settings.arguments.
A bit more generic.
Right. Or for more complex scenarios, you'd use a state management solution like Provider or BLRC to make data accessible where needed.
State management comes up again. Okay. So the navigator class itself, what's its main job?
It's the manager of that stack of routes, screens. It provides the API, push pop, push replacement, etc., for manipulating that stack and controlling the navigation flow of the app.
The root stack manager. Got it. Fitted box. What does that do?
Fitted box scales and positions its child widget to fit within its own bounds according to a specified fit property, like boxfit.contain, boxfit.cover.
So it resizes the child to fit inside itself.
Exactly. Ensures the child fits without overflowing the fitted box.
Cupertino versus material design. Key differences.
Two different design languages. Material is Google's system, common on Android and WebThink app bar, floating action button, ripple effects. Cupertino is Apple's iOS-style Think navigation bars at the bottom, different slider switch appearances, specific page transitions.
So choose based on target platform or desired cross-platform look.
Generally, yeah. Material is default. Cupertino gives that iOS feel. You can mix them, but usually stick to one for consistency.
And the material design icons package
Just provides a huge set of standard material design icons ready to use in your app. Import the package, use the icons class, icons.add, icons.home, etc. Scalable vector icons.
Convenient. Last beginner one. Object dynamic var. Differences.
Object is the base class for everything in Dart. A variable of type object can hold anything, but you often need to cast it to use specific methods.
Base type.
Dynamic essentially turns off static type checking for that variable. You can hold anything, and you can try to call anything on it high kiss. Errors only happen at runtime if the method doesn't exist. Use sparingly.
Type checking disabled. Risky.
Can be. var lets Dart infer the type from the initial value assigned. Once inferred, the type is fixed for that variable. You get type safety without writing the type name explicitly.
Type inference. Okay, that covers the basics well. Ready to move up a level.
Let's do it intermediate level. Build context.
Yeah.
This comes up everywhere. What is it and why is it so important?
Build context. It's basically a locator. It tells a widget where it is in the giant tree of widgets.
It's address in the tree.
Exactly. Every widget gets one when it's built. It's the handle a widget uses to interact with its ancestors.
How does it interact?
Through the context, a widget can find the nearest theme, theme.ofcontext, the media query data, mediaquery.ofcontext, or the navigator, navigator.ofcontext, further up the tree. It's the link between a widget and the rest of the framework.
So essential for finding things and navigating. Got it. What about build modes? Debug, profile, release.
Right. 3 main modes. Debug is for development, enables hot reload, hot restart, asserts debugging tools, not optimized.
Day-to-day mode.
Exactly. Profile is for analyzing performance. It's compiled like release mode, AOT, but includes profiling information so tools like DevTools can track performance. You can't debug in the normal way, though.
You're in performance testing.
Yep. And release is the final build you ship to users, fully optimized, AOT compiled, smallest size, debugging info stripped out, fastest execution.
The one for the app stores?
Okay.
Okay. Widgets app versus Material app, or Cupertino app. What's the difference? Widgets app is the bare bones foundation. It provides the core services like navigation, basic theming structure, but almost no visual styling.
Minimalist base.
Right. Material app builds on Widgets app and adds all the material design specific stuff themes, widgets like scaffold, material page routes, ink splash effects, etc. Cupertino app does the same, but for the iOS Cupertino style.
So you usually start with Material app or Cupertino app unless you're building a completely custom design system.
Pretty much, yeah. They give you a lot out of the box for those design languages.
Makes sense. Let's revisit the stateful widget lifecycle. Can you list the main methods in order and briefly say what they do?
Okay, the sequence create state is called first by the framework to make the state object.
Makes the state.
Then init state runs once for setup. After that, it change dependencies is called a first time, and again later if any inherited widgets, it depends on change.
Reacts to dependencies.
Then comes build, which runs many times to create the widget's UI. If the parent rebuilds and gives the widget new configuration, the update widget, old widget is called before the next build.
Handles property changes.
Right. Calling setState marks the widget as dirty and schedules a build. If the widget is temporarily removed from the tree, deactivate is called.
Temporary removal.
And finally, when it's gone for good, dispose is called for cleanup.
That's a comprehensive life cycle.
Oh.
Okay, keys, we see them pass sometimes, like the sum value. Why are keys needed?
Keys are identifiers for widgets. Their main job is to help Flutter's rendering engine identify and differentiate widgets, especially within collections of widgets of the same type.
Like items in a list.
Exactly.
Yeah.
If you reorder or modify a list, keys help Flutter match the old widget state to the new widget position correctly. Without keys, it might mix up stateful widgets or rebuild unnecessarily. They preserve state across rebuilds and structural changes.
So they maintain identity, crucial for lists.
Yeah.
Okay, expanded versus flexible. We know expanded fills space. How is flexible different?
Expanded forces its child to fill the available space. It's essentially just flexible fit, flexfit.tight.
Ah, so expanded is a specific type of flexible.
Right, flexible itself is more, well, flexible. By default, flexfit.loose. It lets its child take up only the space it needs, up to the available space. But it can expand if needed, or if you set fit, flexfit.tight.
So flexible offers more control over whether the child must expand or just can expand.
Precisely. Expanded is greedy, flexible can be loose or tight.
Got it. Extension methods in Dart, what are they?
Extensions let you add new methods or properties to existing classes, even classes you didn't write, like string or widget.
Without modifying the original class.
Exactly. You define an extension on a type, and then you can call your new methods on instances of that type as if they were built in. Super useful for adding utility functions or Fluent APIs.
Like adding a padding method to any widget.
That's a classic example, yeah. Very handy.
Cool feature. The mounted property in state objects, what's that for?
Mounted is a Boolean flag. It's true if the state object is currently in the widget tree and false if it's been disposed of.
Why check it?
Crucially, you should check if mounted before calling zState inside asynchronous callbacks, like after a network request finishes. If the user navigated away before the callback fired, the widget might be gone, and calling setState on an unmounted state crashes the app.
Ah, safety check for async operations. Very important. Sound null safety. What's the core idea?
Null safety makes types non-nullable by default. A variable like string cannot hold null unless you explicitly say it can by adding a question mark. String.
Non-nullable by default.
Right. And the sound part means the compiler guarantees this at compile time. It catches potential null errors before you even run the app. Leads to much safer, more robust code, and fewer runtime crashes.
Big improvement for reliability. Mixins. How do they work for code reuse?
Mixins let you mix in functionality from one or more source classes into another class without using traditional inheritance. You use the to the with keyword.
Like copying methods and properties.
Sort of, yeah. The class using the mixin gains access to the mixin's members. It's a way to share code across different class hierarchies. You can also constrain a mixin using on to say it can only be used with certain types of classes.
Code reuse without strict inheritance.
Okay.
App lifecycle state.
Huh.
What are the different states?
This enum tracks the state of the whole application. Resumed means it's visible and interactive.
Normal state.
Inactive means it's visible but not getting input, like during a phone call interruption. Paused means it's in the background, not visible.
Minimized or screen off.
Right. And detached means the Flutter engine is running but not attached to any UI view, like during startup or shutdown.
Got the lifecycle states. Image loading. Network image versus image.network.
Image.network is the widget you put in your tree to display an image from a URL.
The display widget.
Network image is an image provider. It's the object that actually fetches the image data from the URL. Image.network uses a network image internally. You might use network image directly if you need the provider itself, maybe for decoration image.
Widget versus the data provider. Makes sense. Async programming. Async await, future. How do they work together?
A future represents a value that will be available in the future, or an error, like an IOU for a result from an async operation.
Promise of a value.
Async marks a function as asynchronous, allowing it to use await. When you await a future inside an async function, the function pauses non-blockingly until the future completes.
Pauses without freezing the UI.
Exactly. Once the future has a result, await gives you that result, and the function continues. It makes async code look almost synchronous and easier to read.
Syntax that simplifies async flow. Good. Resize to avoid bottom inset and scaffold.
That Boolean controls whether the scaffold's body resizes, shrinks. When the keyboard pops up, default is true.
To prevent the keyboard covering input fields.
Usually, yeah. It tries to keep the focused input visible. You might set it to false if you want to handle keyboard overlap manually with padding or scrolling.
Okay. Animation basics. Animation and animation controller.
An animation object just represents a value that changes over time, like a double going from 0.0 to 1.0. It doesn't do anything on its own.
The changing value.
The animation controller drives the animation. It manages the timing, duration, tells the animation to start, stop, reverse, and generates the ticking values based on vsync.
The engine driving the value change.
Right. You usually link them with a tween, defines start-end values, and maybe a curve defines the rate of change. The controller updates the animation value, and you use that value to build your UI.
Got it. Stream versus future. We know future is one value. What about stream?
A stream is a sequence of asynchronous events or data over time. It can emit 0, 1, or many values, possibly ending with an error or a done event.
Multiple values over time.
Think of a stream of user clicks, data from a WebSocket, sensor readings. You listen to the stream and react to each event as it arrives. Future is one shot. Stream is ongoing.
Clear distinction. How do we create our own custom widgets?
You extend either stateless widget if it's immutable or stateful widget if it needs internal state. The main thing is overriding the build method. Inside build, you return the widget tree that defines your custom widget's appearance and structure, usually composed of other existing widgets. Define a constructor to accept parameters.
Build defines the structure. And for stateful.
For stateful widget, you also create a companion state class where you hold the mutable state and call setState to trigger rebuilds when that state changes.
Right, manage state in the state class. Typedef in Dart, what's that for?
Typedef lets you create an alias, a new name for a function type. Especially useful for complex function signatures with many parameters or generics.
Like a shortcut name for a function shape.
Exactly. Instead of writing void function string int everywhere, you can define typedef string callback eat void function string int, and then just use string callback. Improves readability.
Nice for complex callbacks. Future Builder, how does that help with async UI?
It's a widget that listens to a future and rebuilds its UI based on the future's current state.
Handles the different states automatically.
Yeah. You give the future and a builder function. The builder gets called with an async snapshot. You check the snapshot state, connection state has data, has error, and return the appropriate UI, like a loading spinner, the data display, or an error message.
Simplifies handling async UI updates. Good. How do we handle exceptions in Flutter?
Standard Dart way is try-catch blocks. Put code that might fail in try, and handle specific errors in catch beal. You can have multiple catch blocks for different exception types. On some exception cache.
Okay, try catch. Any other strategies?
Definitely log errors, maybe show user-friendly messages using snack bars or dialogues. Sometimes you might implement retry logic for network errors. Handle specific known exceptions gracefully.
Makes sense. Dev tools. What are some key features?
It's a whole suite. Flutter Inspector for exploring the widget tree and layout. Timeline View for performance profiling, CPU, frames. Debugger for breakpoints and stepping through code. Logging View. Member Profiler. network inspector.
A whole toolbox for debugging and profiling.
Absolutely essential for anything non-trivial.
Factory constructor. What makes it different?
A normal constructor always creates a new instance of its class. A factory constructor doesn't have to. It can return an existing cached instance or even an instance of a subtype.
Doesn't always create a new object. Use cases.
Implementing singletons is a classic one, or returning cached instances for performance, or deciding which subclass to instantiate based on input arguments.
Okay. And speaking of singletons, how do you typically make one in Dart Flutter?
Usually make the default constructor private, e.g. myClass.internal. Then create a private static final instance myClass.internal. Finally, provide a public factory constructor that just returns that private instant back to my class instance.
Private constructor, static instance, factory getter. Got it. The event loop. How does that work in Flutter?
Dart is single-threaded, but the event loop manages concurrency. It has two queues, the microtask queue and the event queue.
Queue.
Yeah. The loop processes all microtasks first, usually related to futures. Then, if the microtask queue is empty, it takes one event from the event queue, like user input, timers, I/O, and processes it. This keeps the UI thread from blocking.
Handles async tasks without freezing. Okay. Provider versus inherited widget for state management.
Inherited widget is the low-level Flutter mechanism for making data available down the tree. Provider is a popular package built on top of inherited widget.
So provider uses inherited widget.
Yes, but it adds a lot of convenience, reduces boilerplate, and provides different ways to provide and consume state more efficiently and with better separation of concerns. Generally easier to use, especially for complex state.
Provider simplifies inherited widget, global key, when and why use it.
A global key is a key that's unique across the entire app, not just among siblings. It provides direct access to the widget or its state or render object it's attached to from anywhere.
Access from anywhere? Sounds powerful, but maybe dangerous.
Exactly. Useful for things like controlling a widget programmatically from outside, e.g. triggering form validation, but should be used sparingly as it can break the normal widget composition flow. Often there are better ways using state management.
Handle with care. Okay, handling user input. General approaches.
Depends on the widget. Buttons, elevated button, etc. have on pressed. Text field has on changed, on submitted. Gesture detector wraps other widgets to detect taps, drags, swipes via its callbacks, on tap, on pan, update, etc. Inkwell is similar, but has material ripple effects.
Specific callbacks for specific widgets and interactions. Got it. Layout builder. How does that help responsiveness?
Layout builder gives you the constraints, min-max width height, from the parent widget before you build your child.
So you know how much space you have.
Precisely. The builder function receives these constraints, and you could return different widget layouts based on that available space. Perfect for adapting UI for different screen sizes or orientations.
Builds based on parent constraints. Cool. Value notifier. Simple state management.
Yeah, it's a simple class that holds a single value and notifies listeners when the value changes. You use it with value listable builder.
How does that work?
Value listable builder takes the value notifier and a builder function. When the notifier's value changes, only the widget returned by the builder is rebuilt. Very efficient for small, localized state updates.
Lightweight state for single values. Media query. What info does it give?
Provides info about the device's display and environment. Things like screen size, media query out of context.size, orientation, pixel density, padding, like safe area insets, text scale factor, platform brightness.
Device context info. Useful for adaptive layouts.
Exactly. Adjust layouts, font sizes, etc. based on the actual device characteristics.
Did update widget revisited? When exactly is it called?
It's called on a state object when its corresponding stateful widget is rebuilt by its parent with different configuration, i.e. different constructor parameters.
Parent passed new properties down.
Right. It gets the old widget as an argument, so you can compare the old properties of the new ones, widget, and react accordingly, maybe update internal state or refetch data based on the new properties.
Reacts to configuration changes from the parent. Animated builder. How does it optimize animations?
Animated builder helps separate animation logic from the widget tree structure. You give it an animation object and a builder function.
Okay.
The key is that only the widget returned by the builder function is rebuilt when the animation ticks. You don't need set state in the main widget. It rebuilds just the animating part efficiently.
Optimizes rebuilds during animation? Good. Animated switcher.
That widget animates the transition when its child widget changes. You change the child. An animated switcher fades, slides, or uses a custom transition between the old child and the new one.
Animates between changing children. Nice for dynamic content. State management overview. Why important common approaches?
It's crucial because UIs need to react to data changes. State management is how you structure the flow of data and updates. Simple state can use set state. For sharing state, provider is very popular, uses inherited widget. For more complex logic, Bloc qubit patterns provide architectural structure. Riverpod is another modern option. Value notifier for simple cases.
Lots of options depending on complexity. Draggable widgets. How?
Use the draggable widget. Wrap the widget you want to drag. Key properties are data, the payload being dragged, feedback, the widget shown while dragging, and child when dragging, what the original spot shows. Pair it with drag target widgets, which define drop zones and handle the drop data.
Draggable carries, drag target receives, accessibility, key techniques.
Use semantics widget to add meaning for screen readers. Semantics label. Ensure good color contrast. Manage focus order, focus node. Provide alternatives for complex gestures. Test with talkback voiceover.
Make it usable for everyone. Persistent list headers, sticky headers.
Use custom scroll view with slivers. Use sliver list or sliver grid for the main content. For the sticky header, use sliver persistent header with a custom sliver persistent header delegate that defines how the header looks and when it should stick.
Custom scroll view and sliver persistent header. Okay, advanced territory. Let's talk slivers properly. What are they?
Slivers are the low-level building blocks for scrollable areas in Flutter. Think of them as portions or slices of a scroll view.
Lower level than list view.
Much lower. List view, grid view, custom scroll view, they all use slivers internally. Working directly with slivers gives you fine-grained control over scrolling effects, like parallax headers, collapsing toolbars, mixing lists, and grids smoothly. They enable lazy rendering of list items, too.
Fine-grained scrolling control. Inherited widget again, but deeper. How does it work efficiently?
When you ask for data, using context.dependent inherited widget exact type myInherited, Flutter registers your widget as a dependent of that inherited widget. When the inherited widget rebuilds and its update should notify method returns true, Flutter only rebuilds the registered dependents, not the entire subtree below it. That's the efficiency.
Targeted rebuilds based on dependency. Got it. Tree shaking.
Yeah.
How does that optimize app size?
During a release build, the Dart compiler analyzes your code, starting from the main entry point. It figures out exactly which classes, functions, variables, and library code are actually reachable and used.
Finds the live code.
Right. Everything else, unused code, dead branches shaken off, and excluded from the final compiled application. Reduces the app's download and install size significantly.
Removes dead code. Cool. Sync. What's its role in smooth animations?
VSync stands for vertical synchronization. It syncs Flutter's animation timers with the device's screen refresh rate. Example, 60 Hz or 120 Hz.
Matches animation frames to screen refreshes.
Exactly. This prevents visual tearing or stuttering by ensuring Flutter only tries to draw a new animation frame right when the screen is ready for it. You need a ticker provider, usually via ticker provider state mixin on your state, to provide VSync to animation controllers.
Keeps animation smooth and tear-free. Isolates. Concurrency in Flutter.
Dart is single-threaded, but isolates let you run code on other threads. Crucially, isolates have their own memory heaps. They don't share memory like traditional threads.
Separate memory spaces.
Yep. Prevents many concurrency bugs. They communicate only by passing messages back and forth using send port and receive port. Ideal for CPU-intensive tasks that would otherwise block the main UI isolate.
Offload heavy work without blocking UI. Testing. Types of tests.
3 main types. Unit tests test a single function or class in isolation. No Flutter UI involved. Widget tests test a single widget, its interaction, and layout, using a mock Flutter environment. Integration tests run on a real device or emulator, testing complete user flows through the app UI, like tapping buttons and verifying results.
Unit widget integration, covering different levels. Custom Painter. For drawing.
Yes. You extend Custom Painter and implement the Paint method. It gives you a canvas object and a size. On the canvas, you can draw lines, shapes, text, images, anything. You use it with a Custom Paint widget. Also, implement should repaint to control when it redraws.
Low-level drawing API for custom visuals. Deploying to stores. General process.
Need developer accounts for both Google Play and Apple App Store. For Android.configure build.gradle, app ID version. Generate a signed APK or app bundle AEB. Upload via Play Console with metadata screenshots. For iOS, needs Mac OS X code. Configure bundle ID, certificates, provisioning profiles via Apple Developer Portal Xcode, build an archive, upload via Xcode, or transport it to App Store Connect, add metadata. Both have review processes.
Setup. Build signed artifact, upload via console portal, review. Got it. Advantages of Flutter Inspector and DevTools.
Huge. Visualize the widget tree. Inspect properties of any widget. Debug layout issues with the Layout Explorer. Shows constraints, padding, etc. Select widget mode lets you tap on the device UI to find the widget in the tree. Refresh tree after hot reload. Essential for UI debugging.
Visual debugging for the UI tree. Flutter activity on Android. Its responsibilities.
It's the main Android activity that hosts the Flutter UI. It initializes the Flutter engine, displays the Android's launch screen, configures the status bar, tells Flutter which Dart entry point, main, and initial route to use, handles Android lifecycle events, pause resume, and forwards them to Flutter, and manages platform channel communication and plugins on the Android side.
The Android container for Flutter. Internationalization. I-18N. Steps.
Add Flutter localizations and Intel packages. Configure localizations delegates and supported locales in Material app. Create .arb translation files for each language. Use Flutter Genel L10N to generate Dart localization classes. Access translations using the generated class like appleizations.ofcontext.hello world. Test different locales.
Set up packages, configure delegates locales, add ARB files, generate code, use generated class.
Okay.
Custom screen transitions.
Use PageRoute Builder instead of Material PageRoute. It has a Transitions Builder callback. This callback gives you the animation objects and the child page widget. You return a transition widget like fade transition, slide transition, scale transition, wrapping the child and driven by the animation. Gives full control over the animation between screens.
PageRoute Builder and Transitions Builder. Custom animation curves.
Extend the curve class. Implement the transform internal double T method. This method takes the linear time t 0 to 1 and returns the curve time, usually also 0 to 1. Apply your custom curve using curved animation, parent.controller, curve, custom curve.
Extend curve, implement transform, apply with curved animation, communicating between isolates.
Message passing. Main isolate creates a receive port, gets its send port, spawns the new isolate, passing the main isolate send port as an argument. The new isolate uses that send port to send results back. The main isolate listens on its receive port to get the messages.
Ports for message passing, no shared memory. The Flutter rendering pipeline, high-level steps.
Widgets. Fig. Element tree, mutable structure. Render object tree, layout paint logic. Zel layout phase, calculates the size of positions. Paint phase, records drawing commands. Compositing phase, combines layers. Rasterization phase, Skia turns layers into pixels for the GPU. Finally, GPU displays pixels.
Widget to element to render object, then layout paint, composite rasterize. Wow. Role of the Flutter engine.
It's the core C++ runtime. Hosts Dart VM isolates. Manages rendering via Skia. Handles platform channel communication. Manages plugins. Interacts with the platform's event loop and surfaces. Basically does all the heavy lifting under the Dart framework.
The C++ core handling, runtime, rendering, platform integration. Platform channels, how do they work?
A bridge for Dart. To talk to native code, Kotlin, JavaScript, OpenJC, and back. Use method channel, most common. Define a channel name, string. Call invoke method from Dart, passing method name and args. Native site implement a handler for that channel method. Does native work, sends result back asynchronously. Used for device APIs, native SDKs, etc.
Name channels for async method calls between Dart and native. Flutter flavors, environments, how?
Use separate main xxx.dart entry points, e.g. main dev.dart, main prod.dart. Configure different settings, API URLs, etc., potentially based on environment variables written in these files. Build run using Flutter run flavor name -t lib main flavor name.dart. Configure native build scripts, Gradle, Xcode to handle flavor-specific app IDs, names, icons if needed.
Separate entry points, build flags, native config, code splitting. How does it help?
Breaks the app into smaller chunks that can be loaded on demand, rather than loading everything up front. Aims to reduce initial app startup time and download size. Flutter support for this, RG deferred components, is still evolving, but aims to load features only when needed.
Load code chunks on demand. Improves startup. Whew. That was intense.
That was an incredibly in-depth mock interview covering, well, pretty much the whole spectrum of Flutter topics.
Yeah, we had a lot of ground there.
We really hope this deep dive gives everyone listening a much clearer picture of the knowledge expected at different stages. Hopefully it boosts your confidence, whether it's for your next interview or just tackling your next Flutter project.
Absolutely. The key, as always, is continuous learning and actually building things. Practice is essential in this field.
Couldn't agree more. Keep exploring, keep coding.
And don't be afraid to dive into the documentation or the source code when you get stuck.
Great advice. Remember to subscribe to our YouTube channel for more mobile app development content, and you can join our WhatsApp community for mobile app developers. All the links are in the description. Thanks for tuning in.
See you next time.